Good morning all. Thank you very much for giving a chance to present my thoughts through this research paper. My name is Shruti. I'm a master graduate in construction management from Deakin University. In this presentation, I'm going to talk about defects in residential building sector and how to identify them in early stages. So the aim of this research is about framework for building defects and their identification technologies, in particularly on case studies of residential buildings in Melbourne, Australia. Topics that we are going to look at is introduction about construction industry and residential building sector, objective of this research, methodology followed, data from literature review and identification technologies, findings from case studies, framework, discussion, followed by conclusion and limitations. It's a well-known fact that construction industry is a huge contributor of country's economic growth. If we talk about Australian construction industry, it is the third largest industry and generates over $360 billion in revenue, producing around 8% of Australia's GDP. This industry divided into three major sectors, named engineering construction, which includes major infrastructure, mining and heavy industrial based projects. The second one, non-residential building sectors, includes offices, shops, industrial premises, hospitals, entertainment facilities. The last sector of the industry is residential building, focuses on houses, flats, home units and townhouses. If we talk about residential building sector in particular, it contributes 5% of annual GDP, shown in right line graph, and provides employment to thousands of people. The below line graph on left demonstrates individual sector contribution in economic growth. X-axis represents years and Y-axis shows revenue. We can see that the red line indicates residential sector contributing over $100 billion revenue from the year 2015. Even though this industry promotes huge economic growth, failures and defects are always a great concern for this industry, as they cause delays before handing over and increase maintenance costs during occupancy of the building. There are so many reasons for the occurrence of defects. First, suppose improper designs, lack of use of building codes, improper supervision, use of low quality materials and machinery, poor workmanship, etc. Despite the fact that inspection for the identification of defects happen at construction stage or at handover, but clients don't regularly involve. So this circumstance makes a gap between quality seen by contractor and clients. Few defects are not settled until clients find after property is handed over to them. So to reduce these effects, identification of defects in the early stages of construction is essential. There are various technologies for the identification of defects in any stage of construction. However, there is a lack of framework which links defects, their potential causes, and suitable defects identification technologies. Hence, the objective of this research is to propose a defect identification and analysis framework, which includes mapping of defects with identification techniques and their causes. If we look into methodology of this research, the first step is to gather information about defect types, causes, and identifying technologies. Based on the findings of the previous study, the authors mentioned that most of the defects are recorded in east and southeast suburbs of Melbourne. So this research is randomly selected 5 different properties built in those particular suburbs of Melbourne. Then the case study analysis was adapted to find out the defects in those selected suburbs. The defect type, cause of the defects, and qualitatively analyzed depending on the court decisions. After listing down all the building defect causes, defects and causes, the bar graph is plotted between the defects on x-axis and the frequency on y-axis. Then the framework is developed by combining the findings obtained from the case studies, which is called defect identification analysis framework. In this, the summary of common defects observed from the literature review are grouped into one table. According to the authors, most common defects observed are like wall crackings, deformation in internal walls and floors, detachment and problems in surface appearance, cracking in interior portions, uh, corrosion of the plumbing system, poor isolation elements, isolation gaps at jams and sills are the common defects. In this slide, the defect causes are grouped in a table, which are collected from different literature review. The defects causes are like environmental problems, design errors, construction faults, incompetence of builders and other stakeholders, poor workmanship, low quality use of materials and machinery are observed to be common causes of the defects. This slide explains about defect identification technologies which were mentioned in the literature review by various authors. The defect identification technologies are advanced sensor-based defect management, infrared thermography, ultrasonic technique, electrotype geophysical methods, and building information modeling defect management. After reviewing the 5 case studies from east and southeast suburbs of Melbourne, all the qualitative data is combined. The most frequent defects were identified and the results are presented in the below bar graph. For example, the defect like water leakage is observed in 5 houses listed under case studies. Thus, its number 5 was assigned to it. Similarly, the frequencies of other defects were determined in y-axis, and x-axis shows different defects observed in all the case studies. Here is the framework of defect types, causes, and identification technologies. Defect causes like design errors, construction faults, poor workmanship, and materials are listed left side of the framework. Defects like roofing errors, cracks in walls, interior portions, leakages in ceiling, water damage to the wall, uneven surfacing, voids in mortar are the different defects observed from 5 case studies are listed in the middle column. The defect identification technologies like sensor-based technologies, infrared thermography, ultrasonic methods, electrotype geophysical methods, building information modeling defect management are listed under right column. The defects then mapped with causes and identification technologies based on the data collected from the literature review. Mapping of defects with the causes and identification technologies is purely based on the literature review. For suppose in the ASD MCON software, the design model is viewed in wireframe mode, and with the help of sensors, the specified 3D region is viewed for detailed analysis. Consequently, the performance is monitored and data recorded by those sensors can be used to compare with the actual design specifications to detect any defects. Incorrect measurements were shown in different colors with the use of measurement tools. Thus, the defects can be observed in any stage of construction or maybe after property is handover. Similarly, if we take internal water leakages or ceiling leakages is the main defect, which is also observed in most of the case studies, these defects could be due to inadequate application of waterproofing, poor roof drainage, and use of low quality materials. Hence, the cause can be broadly categorized under construction faults. Counterwise, sensor-based technologies can also serve as an early identification tool of these defects related to leakages. If the defects are identified in early stages of construction, corrective measures can be taken by changing the design or by maintaining quality of the materials. This framework can be helpful for the construction or quality managers to identify those building defects in early stages of construction. There are few limitations in this research. The first limitation is there are many number of cases registered in WCAT database, only few were selected, and field observation was not conducted to validate the findings, and the framework is developed purely based on literature review. so the findings may not be generalized. Thanks for bearing with me.